Good afternoon, everybody. Today I'll be explaining about Heap data structure. So you can see the picture on the screen, which contains four different trees. So among this, we'll understand which among this can be called as a heap. We can see four different trees. So for a tree to be called as a heap, it need to fulfill two properties. One is called as the structural requirement or the structural property. The other one is called as the parental dominance property. So what is the structural property? For a tree to be called as a heap, first of all, it should be a almost complete binary tree. In the sense, apart from the last level, all other levels should be complete. Such a tree is called as a almost complete binary tree. And if at all, if some leaves are, some child are missing, it should be only missing on the right hand side of the tree. So this is the first requirement for a tree to be called as a heap. That is, it should be almost complete binary tree. The second requirement is the parental dominance. In the sense, so when we talk about heap, there are two types of heap, that is max heap and min heap. So here I'll be considering only the max heap. So for a tree to be called as a max heap, the value of all the parent node should be greater than its children. So keeping these two properties in our mind, so we'll discuss, okay, so which among these four trees can be called as a heap. Let us go for the first tree labeled as A, and clearly first we see, you can see the structure of this. This is not a complete binary tree. The reason is that the parent with the value 8 is not having the right child. But 5, which is on the next level, is having the left child. So when we consider the structure itself, we can clearly say that it is not a heap because it is not fulfilling the structural requirement itself. So there is no necessity to check for the parental dominance. On the other hand, all other trees, you can see structure wise, they are all complete binary trees. But just because they are complete binary tree, we cannot call it as a heap. So structural requirement is fulfilled. Let us check for the parental dominance of each one of them. Let us go for the tree which is labeled with B. Let us start from the root. So root is having the value 10 and its children are having value 8 and 6. So at this level, it is a heap. Let us check for the next level, that is the children of 8 and 6. If you consider a child 8, the children are 4 and 5. The value 4 and 5 is lesser than 8, so it is maintaining the parental dominance. When it comes to the right child of 10, that is 6. The left and right child of 6 is 1 and 2. So here also it is fulfilling the parental dominance. So in this case you can see this tree labeled B is having the structural requirement and it is also fulfilling the parental dominance. So you can say this is a heap. Let us go for the next tree labeled C. So as discussed before, C and D are also a complete binary trees. But whether parental dominance has been maintained, so let us start from root. So the children of root is 5 and 6. 10 is greater than 5 and 6. So at this level the parental dominance is maintained. But when it comes to 5, you can see the children of 5 are 4 and 8. 8 is greater than 5. So the value of the child is greater than the parent. So obviously you can say this is not a heap. Though it is fulfilling the shape requirement or the structural requirement, it is not maintaining the parental dominance. So clearly we can say that C is not a heap. Let us go for D. The value of the parent in the tree D is 5, but their children are 8 and 2. So obviously at the first level itself, it's violating the parental dominance. So you can say that this is not a heap. So clearly you can see that among A, B, C, D, only B is a perfect heap. Okay, in other things either parental dominance is not maintained or the structural requirement is not fulfilled. So if they are not, they cannot be called as a heap. So I hope I was able to convey the reason why B is called as a heap. So that's all for today. So thank you all for patience listening. Thank you.